This problem and all other Calc 152 problems can be found here at Sarai Studies. Link is in the description box below. Don't even read the problem, just skim through it. If you see the word volume, then think of FaceTime, like FaceTime on your phone. And if you continue skimming through and you see the word revolving, revolved, then think, oh, a clock revolves around time, so we're going to be using time to solve our problem. If you saw volume and you did not see revolve, then it would be that would be a problem from last section where we just found volume given a cross section. The first thing to do is to find the terms that our problem is going to be in. The terms depend on two things. I call it the AM, so think of morning time. A is your axis of rotation, which is always given to you. That's x is equal to 4. M is the method that you're going to be using. Now, what's my thought process into choosing the method? Well, I like to work backwards. I like to determine what I would prefer my entire problem to be in terms of. And how do I determine that? I look at the curves. What are they in terms of? They are in terms of x. So I would like to keep it that way, because if I had everything in terms of y, then my curves would also have to be in terms of y, meaning I would have to rearrange this so x is equal to y, where the variable is y, the terms is y, and then here I would have to rearrange it so that the x and y are on different sides, and that would be more work. Now I ask myself, is this the same or is it different? This is the same as this. So, remember your methods. Disk and washer go in one, shell goes in the other. D for different, S for same. These are the same, so you're going to be using shell as your method because S stands for same. So shell is the method we're going to try first. This doesn't mean that it's the easiest method, but for now it is the method that's going to give us the least amount of work, because what this means is that our functions are going to have to be in terms of x, or in this case, the curves they give us are going to have to be y equals something something x, where the variable is x, and that's already true for both of these. They're in terms of x because the variable is x. This means that when we do an integral, because for all of these problems we'll have to do an integral, and an integral may have f of something, d something, what goes in here? Well, it's going to have to be x, and then our bounds are even going to be from x is equal to a and x is equal to b. If it was y, then it would be everything y. So we're going to have a dx, and also our bounds are going to be from x is equal to a to x is equal to b. So we took care of that. Now we skip this step and we move on to this step, which is the method. Here we will confirm if this is the easiest method to do by graphing it and seeing if we see a split integral or not. Y is equal to x is super easy. It's just a line. If you ever forget, you can just do an x and y table. X equals to 0 is right here. Now for this one, I can divide by 2 to get y by itself. So y is equal to x over 2 plus 4 over 2. This becomes 2. And this is a 1 times x, so I can take out the 1/2. So 1/2 x and then plus 2. So that's my equation. So it's really a line, and the intercept is at 0, 2. So right here. And the slope is 1. So remember, rise over run. So 1 up and then 2 to the right. So you know it has positive slopes. You want to know if it's going to be something like this or if it's going to intersect with this line, so you can just set these equal to each other. So 1/2 x plus 2 is equal to x. Take this to the other side, so minus 1/2 x. Take out an x, so 1 minus 1/2. 1 minus a half, if you have one whole and you're taking half of it, you're just left with the other positive half, like so. This is equal to 2. To get rid of this, you could do times 2 on both sides, gets rid of this, and you're left with x is equal to 4. So they intersect at x is equal to 4. So let's say that's 1, 2, 3, 4. Let's say 4 is right here. So they're intersecting this way. So let's keep that work over here in the I part, which stands for interval, but it also stands for intersection because sometimes you find your interval by looking at the intersection points. Now this here is our region that's enclosed by all of these graphs, our region R, and we're supposed to revolve this about the line x is equal to 4. So x is equal to 4 is right here. So we're supposed to take this region and revolve it, and then if this is this, then this is this, and this is this, and it's going to look something like this, like a drum, something like that. But that doesn't matter. Now you want to make sure that shell does not give you a split integral. If not, then you can continue with shell. So how do you do that? Well, just remember, you can use your strips. So strips are the lines that cut up your region. They either look like that or they look like this. So if you're using disk or washer, then the strips are perpendicular to the axis of rotation, but otherwise they are parallel. So that's if you're using shell. So they should be parallel to the axis of rotation. The axis of rotation is a line we're always revolving around, so that's x is equal to 4, so they should be parallel, so they should be like this. Now let's zoom in. If you keep drawing parallel lines, if the entire time the top function, the top curve is always the same, and the bottom curve, the curve that they're touching is always the same, then you will not have to do a split integral. So you're fine. So we don't have to do a split integral, so my decision is to stick with shell. So then volume is equal to 2 pi integral from one point to the other, and shell is just radius times height. But again, functions of x, because the radius and height change for every single one of the cross sections that we do. So r of x and yx, because we determined in step 1 that everything was going to be in terms of x, including our bounds, and h of x and then dx. Now to find the radius and the height, I like to think that they depend on what terms my problem is in. So I like to do a cheat sheet regardless of what terms that I chose. So terms of x, terms of y. I start from the inside out, so think of the movie Inside Out. Top minus bottom are the same, and then on the outside it's right minus left, right minus left. And then for this one, if I see x here, I'm going to put in an x here and then a box. And then for this one, if I see y here, I'm going to put in a y here and then a box. Now what's the path that I'm going down? Well, I decided my problem is going to be in terms of x. So I'm going to go down this path because this is the terms of x path, and then to find the height, I'm going to go down this path. Let's work on radius first. What's the number that's going to go in here? It's always going to be this number, the one in your axis of rotation, as long as it's an equation. So that's going to be 4. Now, this does not necessarily mean that x is right and 4 is left. We actually have to figure that out by graphing. And we can use our strips. So just draw one of the strips. Let's zoom in. Just draw one of the strips. We know that they have to be parallel to the axis of rotation. The axis of rotation is x is equal to 4. So parallel will look like this because we are using shell. Now, what's the location of the strip? Well, it's at this x value, right? And the radius is essentially the distance from the axis of rotation until that x value. So this distance right here. And so here, this is x is equal to 4. So we have 4 minus x. So in other words, 4 is the rightmost and x is on the left. So it ended up being true that we're doing right minus left, and it's 4 that's in the right, and so minus left, which is x. So our radius is going to be equal to 4 minus x. Again, it's the distance from the axis of rotation to this strip. So this length right here, what is it? Well, it's just going to be, what is it over here? X is equal to 4. And then here, x can be equal to x. It could be any x. That's the idea. We don't know what it is. It's just some x. And then our height is going to be top minus bottom. What do we mean? Well, that's just the length of our strip. So how can we find the length? Well, it's going to be top minus bottom, right? The top curve. What curve is it touching at the top? This one, 1/2 x plus 2. And so then we want minus the one it's touching at the bottom, and that's this one. That's x, so we're going to do minus x. So h of x is equal to top curve minus bottom curve. So let's move that over here. Now we have our radius, we have our height. Last thing we need are our bounds. So our bounds is where the region starts and ends, and since it's x equals to a and x equals to b, it's going to be on the x-axis, it's going to be lines like this. So it starts here at x is equal to 0, and it ends here at x is equal to 4. And I only know it's x is equal to 4 not only because they told me the axis of rotation was 4, but because I know that these lines intersected at 4 because of this little thing that I did here. So make sure you label your intersection points. So your interval is from 0 to 4, like so. So then my volume is going to be equal to 2 pi 0 to 4 of the radius times the height dx, and this is our setup. Now we go on to this step, which is to evaluate that integral. So this is 1/2 minus 1, so you're going to be left with negative 1/2 x. Then this really becomes 4 minus x times negative 1/2 x, then plus 4 minus x times 2. So this would be 8 minus 2x, and this would be negative 2x, and then positive 1/2 x squared. So this is negative 4x if we get rid of this. And then this is just power rule. So here there's a 1, so plus 1, that's 2, so divide by that same thing. So 4 divided by 2, that's 2. It's a negative x to the second power. Here there's a 2 plus 1, that's 3. Divide by 3 or multiply by the reciprocal. So 1 times 3, that's going to be 1/6x to the third power. And then here we just add a variable, so plus 8x. And this is all being evaluated from 0 to 4 multiplied by 2 pi. And then fundamental theorem of calculus says take this, plug this in, get an answer. Then minus, take this, plug this in, get an answer, and then get your final answer by subtracting. So here we plug in 4. We get 4 squared, which is 16, times 2, which is negative 32. 4 cubed is 64 divided by 6, and then 8 times 4 is positive 32. So these 32's cancel out, and we're just left with 64 divided by 6 multiplied by 2 pi. And 64 times 2 is 128, and then we have pi divided by 6. And we can simplify this. This becomes, well, 64, and this becomes 3. Your final answer, 64 pi over 3 cubic units. Do not forget your units, and that's it for this video. I'll see you in the next.